Okay, so for this direct proofs problem, we have to solve for G or D. No, and the two premises are if F then G, or 8 or E. And the second premise is F and A and not 8 or E. So, and solve for G or D. So the first step to solve this, we have to take in from line 2 F and A through simplification. So F and A from line 2 through simplification. The second step, and if you have F, then you will also have A because they are united through AND. The second step is to simplify further. We take F out of line 3. So here, because the rule of simplification says that Q and Q, therefore P. So meaning that if you take one, you have to take both. So to simplify further, just take F and from line 3 through simplification. The third step would be we have to simplify the other part of line 2. So don't forget that there's the other half of part 2, this one. And that we take out not 8 or E from line 2 through simplification. And then for the step number 4, through disjunctive syllogism that says that P or Q, not P, therefore Q. That is the rule of disjunctive syllogism, meaning that if you don't have one, then you will have the other. So we take out F then G from lines 1 and 5, and that's a disjunctive syllogism. And for the last step, because we proved that F was true, so if F then G, we proved that F was true, therefore G. So G through modus ponens, this is the rule, we take from line 4 and 6, modus ponens. And the last step is addition, and the rule of addition says that we can add everything we want. So we put G or D from line 7 through addition. And that's it for A, number 1. So for problem number B of direct proofs, we have to solve for D or G. We have 3 premises. The first premise is A and F or G, then D. Premise number 2, B or C, then F. And the third premise is A or E, then B and C. And we have to prove that D or G is true. So the first thing we need to do is take the A out of the first line through simplification. And then because of A, since it's an AND statement, so here, we also know that we have A or E. And here, through line 4, through addition, because we can add everything we want. So we have here 8 and 8. And step number 3 is that if we have A or E, we would have B and C. Because if we have A or E, then we will have B and C from line 3 and 5 through modus ponens, because if this, then that, therefore that. So if this, then that, so therefore yes, here. So step number 4 says if we know that we have B and C, then we would have B through simplification. So we just take B from line 6 through simplification. Then step number 5 says that we have to, so step number 5 says that if we have B, then we would have B or C. So we add, because we want to, through addition, we just add the C, the B or C. So we add, as we said, addition, we can add everything that we want. So through line 7, we add the B or C. And then step number 6 says because we have B or C that was added, we see up here that we have f through mode exponents. So f will be through lines 2 and 8. So here we have f, and then through line 8, we see that f will be true through mode exponents. So lines 2 and 8. And then step number 7, that's up here, says that if we have f, then we have f or g through addition. So as we said, we can add everything that we want, and we added f or g. And then step number 8 says that means if we have f or g, that means we also have d through mode exponents. So from line 1 here, d, and line 11, that is this one. So d through lines 1 and 11 through mode exponents. And then the last step, that is step number 9, that is number 12, says that if we have d, then we will have d or g through addition. So through line 11, we just add g or g through addition, and that's it.